Okay, we're going to be looking at a couple different tests here in this section. The first one we're going to take a look at is called an integral test. So I'm going to make probably 2 videos. Integral test is used when the function is positive, continuous, and decreasing for all values at 1 and after. Okay, then if that's true, if those conditions are met, we can say the series would converge if the integral converges. Or we can say that the series diverges if the integral diverges. All right, so the first thing we want to do, we want to take this and turn it into an integral. So we're going to go from 1 to infinity for 1 over n squared. Now I'm going to change it to x just because that's what I'm used to. If you leave it as n, it's not a big deal. So we know that this is an integral that we have dealt with before. So something with infinity in it. We know we need to take the limit of that. Okay, so we're going to take the limit as b approaches infinity. From 1 to b for our integral. Okay. So I'm going to kind of go through this quick because we've done these before. So the integral of 1 over x squared plus 1 is going to be arctan, or inverse tangent. So we're taking the limit as b approaches infinity for arctangent. And we're evaluating at b, so I'm skipping a step here. So we're going to evaluate it at b minus arctan evaluated at 1. Okay, so we're taking the limit of this whole thing. So we know arctan, so inverse tangent would be pi over 4. So tangent of pi over 4 is 1. And then arctan to infinity, we know the limit for arctan to infinity. We need to think about that asymptote. And we have pi over 2. So pi over 2 minus pi over 4, we're going to get pi over 4, and we can say that it converges because we get a finite value. So it converges, and we are using the integral test. Converges by integral test. Okay? So it's that simple. So if we get a finite answer, we can say that the series converges. If it's some other value like does not exist or infinity or something like that, we can say it diverges. All right, so this one, let's go ahead and set it up. We have, I'm going to skip this first step there. So we're going to go from 2, so that bottom number, 2 to b, because it's infinity. We're going to run that limit. B approaches infinity for 1 over n times natural log of n. So I'm going to rewrite this a little bit. I'm going to rewrite it like this. It's a little easier to see what the integral is going to be, unless you just know it. All right. So if we use u substitution, we can take the natural log as our u, and our du is right here. So that would turn into that, and we would end up with the natural log of the natural log of x. evaluate it from 2 to b. So you can probably see what's going on here. We have that limit still. And if we plug in b and we think about the infinity, minus natural log of, I mean, we really don't have to show all this, because we know, if we look here, if we look at this first one, the natural log of infinity is just going to be infinity. So this diverges, because this is infinity right here. That one right here. And it's going to diverge. So it's diverging by use of the integral test. Okay. All right, so I'm going to stop there and I'm going to make another video for it.